Right, welcome everyone. Thanks for joining us, especially you, Mike. Obviously, another session of AI research and development with Mike Nedelko and Digitalent. Really keen to hear what's been happening over the last month or so. We had a lot of success with the last one, some really interesting topics that you covered. And I guess a lot has changed again over the last month. So really keen to hear from you, mate, what's been going on and what kind of insights that you have.
This works. Well, thanks everyone for joining. Thank you very much, everyone, for waiting. Really appreciate you all taking the time. Just to quickly introduce myself a little bit, and I hope you can see the presentation here on the screen. My name is Mike. It is very nice to meet you all. I am a CPO and a technical product manager. I've been an AI and ML enthusiast way before it was cool. I've been playing with the neural networks and the old NLTK based on Java since approximately, I think it was 2008, even before TensorFlow was really a thing. And through my work, I really get to apply this passion. I manage 4 engineering teams that are predominantly focusing on delivering AI and ML-driven value propositions. And what that does is it requires me to sort of really revel and very, very closely follow the AI and machine learning developments and the space as well as the research. And that makes it really easy for me to hold presentations like that, which are essentially about the latest developments in AI, which is essentially what we're going to do today. Now, standard disclaimers. With a community and audience like this, it's a little bit difficult to gauge the level of granularity that everyone desires for us to apply here. So I'm going to give you a little bit of a heads up. What is happening is I'm going to keep this particular session more at a 1,000 feet conversation. So it won't be a conversation that is going to be at a 10,000 feet level. So we're going to go into a little bit of detail, but we're not going to cover any math or any coding. None of that is required, right? It is intended for everyone to be able to follow along and understand the gist of what is happening in the AI research space and has been happening throughout the month of August. So what does that mean for you? It means if you are an AI researcher yourself and you are working in the artificial intelligence and machine learning space, there is a chance that you may have heard about some of the concepts that I'm going to cover. You might not have heard them in that sequence, which could still be valuable because it sort of highlights particular themes and trends. But you're probably aware about sort of the general thrust of what we're going to talk about, because obviously it is your job, right? If you're not a researcher or a deeply technical individual, what I hope to do is to take what I believe are the 3 most prevalent paradigms that we have been observing in the AI research space over this year or this year up to this point, and illustrate those with the most recent papers that have come out in sort of the last 30 days alone. So everything is very recent, everything is very fresh. And what we're going to do is we're going to go through those. We're going to weave a story around this narrative that sort of allows us to put all of these developments into context and allows particularly product people like myself and maybe yourself get a feel of where all of this is going, right? And so the way I will break this out today is going to be in 3 parts, right? First, we're going to do a very brief check-in on last month's topic, because AI research is a building field, right, in which sort of the central themes and paradigms we talked about last month continue to be present. They're just, being put on steroids, right? As Dylan, you mentioned, a lot of things have changed, right? And then we're going to talk about how these paradigms have evolved over these last 30 days in these papers, and are going to observe what these general strategic directions are that are represented there. From that framework, you can probably tell that I'm not going to be likely to cover everything that is going on from a research perspective in the AI field in the month of August. There's just too many papers. I believe every day we have enough papers to be able to fill a conference room entirely. So we're going to be rather selective. If you have any questions about any other research that you've heard about, feel free to contact me. My contact details here are on the slide and also at the end of the slide, and then we can chat about it. I'm always up for a little bit of an interesting chat, if that makes sense. So what we're going to do is we're going to dive into a few papers, but before we get started, we will start with a little bit of levity and a quick experiment you can run yourself. So you may have seen this making the rounds on the internet this month, but there is an interesting behavior and an interesting perspective that is particularly fun to explore with this example. And this example is essentially replicatable across all major AI products at the moment. So what happens is if you go to GPT-4 or Claude or Meta, if you go in and type in the question, how many R's are in the word strawberry, right? It is very likely going to give you the wrong response, right? And you can see the results here. And I have to add a little bit of a disclaimer here is that if you are using the paid GPT-4, which was specifically tuned for complex tasks, you may on occasion get a more correct answer, but it is not consistent. If you open another window, ask the same question, you're going to get the wrong answer again eventually. The reason for this is that a GPT-4 is essentially tuned aside from trying to build a conceptual understanding of how of what the answer is. It creates little cheat sheets the way, you know, maybe an elementary school student would create a cheat sheet for a test, puts it in his pocket and goes, oh, well, enough people have asked me how many R's are in strawberry, and enough people seem to have fervently disagreed with my response on numerous occasions. So, you know, maybe I just take out that cheat sheet once in a while, look at the question without really look at the answer without really understanding the question, and give you the right response. Again, however, it is not consistent, right? And the reason why this happens is that the word strawberry is made up of essentially 3 tokens. You can see that here through the token calculator. And for anyone who doesn't know what tokens are essentially the operational units that LLMs use to process information. In the case of text, what you do is you chunk a particular word into a chunk of letters and spaces and characters that are then converted into a numeric value. You can see that here. And the difference between human cognition and machine learning cognition is that when we humans look at a word, right, we see the word in its entirety and we can count the R's in the word. But when AI looks at the word, it doesn't see the word. It only sees those numeric tokens, right? It sees those numeric tokens being represented by numbers, and then it relies on its probabilistic model, which it is trained on, to guess the next best output in the sentence that it is currently generating for you, right? You may have heard that LLMs are large prediction machines that determine what comes next in their output. Now, I share this particular example with you for a particular reason, right? And that reason has something to do with this month's major theme that was sort of observed when looking at the huge body of work that has been created in the last 30 days from the papers. And that theme is distributed autonomy, right? And this can sound a little bit scary, right? Because what we have also seen is this month, or in the month of August, that machine learning researchers have achieved a new AGL ARC high score. For those of you who are unaware what that is, it's an intelligence benchmark that intends to measure solving particular tasks to which the AI specifically doesn't yet know or has never been provided with the responses or example responses before, right? And what that benchmark does is it takes the AI's performance and measures it against the human baseline, right? And a new benchmark has just been created. And what that means, of course, is that while AI is becoming more and more self-directed, and it is becoming smarter and smarter, right? The takeaway of this little introduction with the strawberry is that AI generally requires businesses to function. Businesses will only survive if they make money, and they will only make money if they effectively solve human problems. Therefore, while AI is getting smarter and smarter over time, right, humans are still needed in order to ensure that when we are deploying these systems at a larger scale, as they're becoming more powerful and involved in our lives, at least from a quality control perspective, right, we are still very, very much needed. Because while this little example with the strawberry is a smaller example that I've just shared with you, right, seems relatively insignificant, right, little errors like that can have dire consequences when we are talking about AI models that are, for instance, designed to solve medical problems, to provide financial advice, legal advice, those kinds of things, right? There is still a human eye needed at all times, right? And why do I mention this? Why do I index on this so hard? Is because, well, the two terms that are sort of defining this month's theme of the research, autonomy and distributed. If you've ever watched the Terminator, right, they should elicit feelings of, oh, well, can we even control this thing moving forward? And the answer is definitely yes, or at least humans are still very much required. But in the themes that we're going to discuss this month, there is definitely a sense that AI is getting so smart that it can be entirely self-directed. At least those have been the papers that have received the most attention this month, right? And this is where we will be doing a little bit of a brief check into last month's topics, because AI research is, as I mentioned, a building field, right, with the central paradigms that we talked about for the month of July, building on into the months of August, right? We've seen here Meta open sourcing Llama 3.1, making intelligence free in essence, the LLM becoming sort of a almost an operating system, kind of playing the role of an operating system that can essentially ingest tasks and then designed to work with a lot of other operating systems to complete tasks, and how this then distributed into the agentization of LLMs, meaning we're not just giving information to one LLM and hoping it to complete a task. What is likely going to happen is we're going to give our task possibly to one LLM, but it then will go out and work with a lot of specialized other LLMs in order to accomplish that task more efficiently, right? And these three themes are very, very much present in the body of work observed in, right? In those research papers but they were very much pushed to the limit or the next level, if I may say. And I think a good illustration of that is the first paper that I want to talk about, which was pretty big news in the AI community, right? And that paper talks about automated AI research and harks back to a pretty seminal publication that we received from a gentleman called Leopold Aschen-Breiner. He is a former OpenAI researcher in AI alignment, and he essentially wrote a paper where he outlined how AI will evolve towards AGI, right? Artificial General Intelligence or superintelligence. And in that paper, he presented this very compelling graph, right? That mapped out sort of the steady growth of intelligence in AI. And he sort of like tracked the advancement from GPT-2 to GPT-3 and 4. But what was most intriguing in that paper is that he associated the prediction of an intelligence explosion specifically with a point where AI surpasses the human capability in self-improvement. So not human capability in general, but just the human capability in the AI improving itself, right? And essentially what Mr. Breiner suggested was that we will get there around 2027. Well, Mr. Breiner did not account for the year 2024 because a company out of Japan just published an AI scientist that is intended to be able to do exactly that, right? So what this particular visualization suggests is that the key to the intelligence explosion, and this is what his paper, you can access that here, suggests as well, is for AI to have the ability to conduct autonomous research, right? Which essentially comprises of the ability to discover new techniques and continuously improve itself, right? And that superintelligence will come about because AI essentially needs the ability to generate new knowledge, sort of test that new knowledge, review that new knowledge, and then incorporate it back into its own learning process without being limited by human intervention, right? Up to this point, and still largely to this day, right? AI improvement is largely directed through humans, and that has certain limitations. Obviously, we can't be online 24/7, right? An AI agent that is designed to be an AI scientist could very much do that. So the company that I'm talking about is called Sakana AI. They have developed a system that automates the entire scientific discovery process. At least that's what they're claiming in their paper. Essentially, what they're saying that the system can do is independent research, creating new knowledge, testing hypotheses, peer reviewing their findings, and even publishing the results in a fully written manuscript. The authors claim that their model can, or their implementation can essentially fulfill the entire research cycle in a fully automated manner. And that has the potential to introduce a capability where the AI can iterate on itself endlessly, improving and expanding on its capabilities essentially 24/7. Now, this is not just a concept. I want to make that clear. This solution is currently running right now. It is continuously generating papers. You can see those papers on the link that I have shared with you. Here you go. If you go to Sakana AI Scientist, you can see all the papers that it generated and continues to generate. I haven't read any of them, but they are it is a really impressive capability that has been widely accepted by the AI community as a meaningful step towards AGI, right? Now, I'm going to quickly talk with you about we're going to quickly dive into the process that is at play here. Essentially what happens is Sakana AI goes ahead, their AI scientist goes ahead and brainstorms a bunch of research directions. So it goes broad first, and then it uses a large language model to generate some ideas based on its existing archive of knowledge. And that can be the archive of knowledge that was provided with by its creators, but also an archive of previous papers that it wrote itself, being able to continuously improve on itself, right? It then checks those ideas for novelty, which is really neat. So it goes ahead and scores those ideas, and those ideas that it continuously refined but didn't necessarily make the cut ultimately get filtered out. They might get filtered out because they're too similar to existing literature, and it does so by communicating with a platform called Semantic Scholar, where it essentially goes and queries Semantic Scholar to see whether the research idea that it is currently focusing on is novel or not, right? It then creates a description as well as an experimentation plan along with an assessment score for interestingness, novelty, and also feasibility that then continues to direct its further experimentation phase, right? And so when it then finally selects an idea, the AI scientist plans and executes a series of experiments, right? It generates its own code, it runs its own code, and then what it does is it records the results and generate plots for these results. So it plots those results out, right? And it repeats this process until it reaches a satisfactory result that has been achieved, right? Which sort of harks back to the self-assessment score that it set for itself in the idea generation phase, right? Then goes ahead and writes an entire manuscript by itself, right? It then conducts web searches and interacts with the internet in order to search for relevant references, right? And if all is well, it goes ahead and publishes that paper for review, but also reviews that paper itself. And if that paper meets a certain grading according to its own quality standards, right? Its own success metrics. It puts that paper in the archive, which will then allow it to continue this process and continue iterating on itself, right? Now, I've included both the paper and the blog post for this particular slide. Feel free to check out either of them. I'm just going to say the blog post is a lot more engaging. I preferred it to the paper, so I figured it might be helpful to provide you with either of those resources if you want to dive into that a little more, right? Now, this obviously is a clear step towards more autonomy, right? And because we have an agent now that is out there and particularly specializes in doing research and how to improve LLMs and AI as a whole. And this very much aligns with the paradigms that we talked about last month, because remember when we talked about the agentization of LLMs last month in the papers that were driving that particular direction forward, right? We also noticed that Meta open sourced Llama 3.1, right? And that meant that everyone was now able to download and run those models, and researchers essentially immediately jumped on the chance to see how effective sort of a distributed compute and learning model could in fact be, right? And specifically, when we talk about agentization and this new compute paradigm, the thrust to the scientific direction inherent in trying to understand how to make these systems more distributed, more specialized, and autonomous is still very much there, was still very much there in the research papers in the month of August, right? So what we're observing here is essentially a paradigm where instead of everyone interacting with one or two models, so you're a business, you give all your stuff to ChatGPT or Claude or whatever have you, right? We are now worrying about those businesses potentially deploying their own LLM models in their infrastructure. You take out the single LLM as the center of gravity entirely, and instead you have a bunch of agents work together to be more efficient and not only solve tasks, but also extend that to the nature of the learning and the training process in and of itself, right? And this is where the second paper comes in that I wanted to talk about, and that is specifically talking about federated learning, FL or FedML. Federated learning is not a new concept in the AI space, but there is a new framework that came out that specifically solves a big challenge that we observe with federated learning up to this point, right? Federated learning is a way to try and solve a particular problem that AI and specifically LLMs have, right? And that is, as LLMs become more advanced, they need a lot more data to sort of keep improving, right? However, unfortunately, what happens is that a lot of data is private and spread out across different devices. Like, for instance, I have different photos on my phone than you have on your phone. And I would consider my photos of my family and myself rather private, right? I'm sure you do so too, right? And so I would guess twice before actively submitting those for training to a machine learning model, right? In addition to that, it is probably difficult for a machine learning model to ingest not just photos, but also very different forms of data that come in, because ultimately our phones are very differently configured, right? They have different memory, they have different CPUs. So there is a little bit of a system and data heterogeneity challenge that is involved in federated learning here. And so what federated learning ultimately is a way to try and distribute the training process across different devices, right? So rather than essentially asking everyone to submit their data into one central LLM or into one central training repository, what federated learning does is it trains the AI directly on the devices where data is stored without needing to collect the data in a shared location, right? And this is really interesting because what that allows us to do is to come up with a system where you are essentially collaborating on training one large language model, right? But do this from everyone's devices with the data that are stored on there without having to share the data across this collaboration, if that makes sense. So I'll explain to you what that means in a second. It'll make sense here in just a few seconds. So what happens in federated learning is that you start with a central server, and that central server selects a global machine learning model, right? That generally tends to be pre-trained, and it's usually pre-trained for the intended use case that you have, but it might also be generally applicable. Like you might be using like a Llama 3.1 or something, right? The global model is then distributed to clients. So you can see here, this is client 1, client 2, client 3. So this might be desktop, this might be phone, this might be something else if the model can run on a phone, right? But just for argument's sake, right? And each of these devices, each of these clients, they hold their own data set. And what then happens in federated learning is that each of those clients trains the model locally on its data and shares the results back with the server in step 4. But it doesn't share the entire results. What it does is it computes the model's gradient. So it computes the difference that show how much the model, the main model on the server, needs to improve given the findings that the clients have. So the clients don't actually share their findings. They just say to the main server, hey, you need to think about this just a little bit different, right? Based on the data that I have, right? The weightings that you observe as part of your training should change in the following format, right? And then what happens, the server takes that, it improves the overarching mother model, if you can say, if you want to call it that, and shares it back out to, you know, the same clients. It redistributes it to the clients, and that process happens over and over again until the model converges, so it reaches an optimal state. That's usually some sort of performance target, if that makes sense, right? And what happens is that federated learning has a few really distinct benefits, right? So I'll show you this here real quick, right? These are the benefits that are being observed, that have been observed in this paper that I'm sharing with you here. And privacy here is very much at the top. So you can imagine there are a bunch of use cases where data privacy in the medical field, in the financial sectors, in many other fields is really, really paramount for businesses to operate in the first place. Sometimes they're legally constrained, there are compliance regulations. Other times it is trust that customers are investing into this business not to share the medical information far and wide, right? And with a federated learning model, what happens is that the data never leaves the local drive of the device that it is trained on. Only the computed gradients are shared, which are generally anonymized and do not contain any private data, right? What this also does from a data security perspective is that it keeps the data decentralized, right? So that remediates any risk that is usually associated with a centralized data storage, such as, you know, data breaches, for instance, right? It's also more scalable because obviously now you have a bunch of machines that are working on training this model rather than one. And it also enables collaborations between different organizations without those organizations having to share their data, which further breaks down data silos and is obviously really useful, right? If any of you have ever worked in a company that was security or compliance sensitive, right? Legal compliance makes sharing data anywhere really difficult. We're talking about GDPR, NIST, SOC, all those wonderful compliance frameworks, right? This particular approach to federated learning provides a solution for that. However, as I mentioned, system and data heterogeneity is a huge problem, right? If you have different devices, those different devices might be running on different operating systems. They might have different hardware capabilities. There might be different network conditions present, and the data on those devices is also different by its very, very nature, right? And that can really affect performance of these federated learning mechanisms. Having said that, though, a new paper came out, and we're going to talk about that a little bit, called FEDMO, right? And this is a new framework where they propose that instead of using a traditional AI models, they use more flexible models with different parts, which they call experts, right? And those experts, and I'll explain to you what that means here in detail, can be activated depending on the specific data or task that they are training on. Remember, every single device, every single client has their own data set, right? If they get really good at inference based on the data that they have, they essentially become an expert. And we're going to walk through this here real quick. It's not, it looks a little bit confusing to begin with. It took me a while to get a handle of it, but ultimately it communicates a really clean message. So I figured we'd go through this real quick so to give everyone an understanding how this works. Essentially, what this does is Fedmo starts out and says, okay, I'm the server, and I'm going to train a base model based on the data that I have, right? I will train the model that I believe is going to provide the foundation for any training that any of the many clients, right, is going to undertake. It then passes that base model to the clients, right? And that client might live on a computer, most likely not on a phone, but for argument's sake, let's say it could be one of those phones. And then what the client does is it uses that model, looks at its own data, trains that model on its own data, calculates the gradients. So those are the differences between the model training results that it just achieved and the model training results that the initial server had, right? And sends it back to the server along with something that's really important here. That is activation information, right? And essentially what activation information is the client goes ahead and looks at its own, neural network and says, hey, mother server, when I trained on the data that I had, there were specific layers in my neural network or specific nodes that were activated quite a lot when I trained it on my data, right? So keep that in mind. I think I'm pretty good at training on phone images of cats, for example, because I had a bunch, in my data storage. And the server goes, oh, okay, that sounds exciting. Let me mark you down as an expert for photos of cats, right? Or a particular type of data, right? Those stuff that you're trained on, right? And the server essentially says, okay, you're now my expert for this kind of data, right? And what happens is, because the server initially, keep in mind, it sent it out to many, many clients, right? It looks at all of its experts and creates what you can think of as panels. It combines them in a smart way to improve the overall AI model. So essentially it says to itself, well, I want to be good at, identifying cats in images. So I have a list of experts that I can draw on. Let me essentially go ahead and combine their power into so-called submodels, right? So it might have one client that's very good at identifying images of cats sitting on sofas, another client that might be very good at cats in the backyard, and another one at cats, eating from the food bowl. And so the server says, yep, I need to have a model that is very good at identifying cats, right? I'm going to put these three together in order to create my submodel. But not only that, I'm going to go ahead and fine-tune these submodels to make them even better. And essentially give them a task that allows them to fine-tune their model even further, right? So the clients go away, fine-tune their stuff, right? Conduct inference, send it back, and at that point the server goes, all right, I now have all the refined, fine-tuned training results, all those gradients back from my various experts, right? I put them into my main model and I repeat the process until I believe I have reached an optimal training level, and then I stop, right? Now you might ask, well, does this work, right? And it does. The results show that this method performs a lot better than previous techniques for training AI in a distributed way. And more importantly, what it does, it addresses the heterogeneity challenge that we previously encountered, right? Because, one client might be too memory constrained to really, complete a particular task, or they might just suck at identifying, cats, for example, if we go back to that example, right? And so they might be good at something else, or just become a politician or something, but they definitely won't be an expert in the eyes of the server, and therefore they sort of fall off in that training cluster, right? So again, we're looking here at a distributed architecture, this time not for generation, but for training, with added benefits, including data privacy, security, performance, and so forth, right? The final significant development, and that continues in the same vein, is automated design of agentic systems, right? So again, going back to July, where a significant part of the body of research was specifically talking about how to make agentic systems work, right? This is now an attempt to take that concept to the next level. And essentially what you see here is you see an agent here, an AI agent. They're essentially AIs that can do stuff. They can make plans, they can make choices about what to do, right? They can select the tools in order to accomplish their tasks, and they can also provide themselves with feedback for, you know, further iteration improvement. And you see an example here of an agent, only this agent wasn't discovered or written by a human. This was designed by another AI, right? And agentic design or automatic design of agentic systems, or ADAS, is a system that was proposed in this paper. It's a fascinating paper, where you essentially have a so-called meta agent generate other agents until it identifies the best possible agent that it can put together. So it's AI creating AI, right? And what that does is the meta agent essentially operates within a predefined framework consisting of essentially a bunch of basic functions. So these are things like foundational model queries. These are sort of like API calls. You can imagine them as API calls to sort of GPT 3.5 or GPT 4 to generate or refine code. They usually have things like prompt formatting or task handling functions for things like text analysis or code execution, right? And the meta agent essentially utilizes this function to write new agent code, if that makes sense. But while it is doing that, the agent essentially starts with a simple, the most simple implementation of an agent that it can imagine, right? It also uses previous discoveries, but we'll get into that here in a little bit, right? Essentially, it starts with a simple agent, and then writes a tester that tests whether the agent that was just created by the meta agent, sorry, a lot of agents in here, but it creates a tester that gives each created agent a utility function. The tester then tests the created agents. It then runs inference, which essentially means it tests those agents. It runs them through the gamut and see what the results are and compares the results to a desired performance level, right? And if those agents pass a benchmark test, it essentially says, yep, this is a good one. I'm going to put that in an archive, and it repeats the process over and over again, right? Now, while it is doing that, the interesting part about this particular paper is that the way this system, the ADAS system, was designed, it was designed in a way to allow the meta agent to think of the task of creating other AI agents as sort of a search space, right? So what happens when you create agents essentially is that you have a bunch of agent architectures, you have a bunch of control flows. Well, let's go back here and see what that looks like there, right? You have different architectures, you have different control flows, you have different prompt instructions. So those are specific ways in which tasks are sort of framed or queries are sort of formatted or formulated. And you have different tools that you can use in order to accomplish the task, right? And when we give ADAS all these variables to work with, ADAS essentially thinks of these items as a search space that it samples from. So when it first starts, it goes, all right, I'm going to first start with a high-level strategy before implementing low-level details. That got it to an agent that performed sort of at this level. That then plateaued, and it said, okay, I need to do something different. I'm going to implement some chain of thought to generate possible answers, right? Which then got it to this level. It plateaued again, and then it introduced dynamic memory to do more refinement. So as you can see, it sort of explores the various methodologies that actual human programmers of agents are using, and it's sort of exploring the search space and is creating more and more agents as it cycles through this process over and over again that tend to perform better and better as we proceed. And you can see here on this side how these agents, how the best agent that ADAS created performed, which at the time when this paper was written, outperformed some of the state-of-art hand-designed agents that are currently out there. So you can see here the accuracy percentage and mathematical tasks, multitasks are sort of like different tasks, different language-based and math tasks that are being provided to the agent, or logical tasks and scientific tasks. It did really, really well, right? And while there is still there's still quite a bit of work to be done in this area, it was generally being perceived as a significant step towards increased autonomy. So this wraps up the three most significant developments that I believe occurred in the month of August. We sort of touched on some of what I would consider the most significant trends that you can see here in blue at the top. And we also went through some of the papers, right? I believe that building on the research that we've seen in July, the major direction that we're currently going into is the entire ecosystem is obviously becoming more open source. As it is doing that, is becoming more accessible, and therefore we're seeing systems becoming more and more distributed, not just from a performance perspective, but also from a learning perspective, right? We've also seen a jump in intelligence itself, and that is being used to create more autonomous systems overall. Specifically in the area of self-directed research and discovery and AI improvement, which is a pretty big deal. And finally, we sort of touched on the continued agentization of the AI space, which seems to have been taken sort of kind of to the next level by automating the design and improvement of agents as a whole, right, with the ADAS system. So I hope you enjoyed this presentation. Thank you very much for spending your lunch hour with me. I hope this helps you a little bit to see the major trends and movements in this very fast-paced, fast-moving space. And I hope this helps you sort of like weave a story around this that lets product people like myself and maybe yourself also see where these things are going. So if you have any questions, right, either feel free to ask them now or feel free to reach out to me. Love to chat with you about it.
Hey, Mike, I've got a question. It's Paul Ramirez here.
Yes. Hi, Paul.
Okay, excellent.
Very nice.
Yeah, hi, how are you? It was a really good
How's it going?
About the multi-agents. I guess a couple of quick ones.
Yes.
So with the agents kind of doing their sort of own assessment, what's your view then on synthesized data in this case? I'm assuming quite a bit of it gets generated. And as you mentioned before with the LLMs, the need to really consume even more sets of data as it gets sort of either created or digitized. Yes.
So I am going to bring up last month's presentation, which specifically talks about the risk of or synthesized data and some observations that are particularly pointing towards the use of synthesized data in large scale applications, right? And one of the major risks that was observed last month is model collapse, right? So if you talk about the agentization of systems, right? If you do enter into a recursive cycle, right, where you're using AI-generated data for training on embeds, right? Eventually, the AI will suffer from the degradation of its results and accuracy through the artifacts that are being generated. And that is a very, very good point, right? Because that is still a challenge that we don't have a super sustainable solution for. And as a matter of fact, it is an issue that is going to become more and more prevalent because the golden days of all data on the internet being created by humans is definitely over, right? And since we don't have a universal identifier that allows you to trace the custody of every single data point that you're ingesting, you might be ingesting artifacts that might ultimately lead to degrading dynamics. And there are people out there in the AI community that say that for every model that's currently being generated, model collapse is inevitable, right? So that's something definitely worthwhile considering. I hope that answered your question somewhat, but I don't think I provided a cohesive solution, because I don't think we have one yet.
Yeah, it actually brought up, got triggered by a question somebody had when their medical device hadn't actually been treated on real patient data. It was all synthesized data. So I guess as this matures, and obviously there's a lot of capability in this space, potentially more devices or more systems will be tested on synthesized data in the future. There'd be a question then on the validity of such devices being used on humans in for medical reasons, for example.
That's absolutely correct. And I also, with regards to synthesized data, this is such an interesting area, because I'm keeping my ear quite close to the AI ecosystem as it exists right now in Australia and overseas. I have friends who work at places like image generation platforms, for example, and the internal view there is that ultimately training on synthesized data is going to be the golden chalice, so to say, right? If you can make that work, you have sort of cracked the code, because then you don't need to pay for your training data anymore. Having said that, though, right now, the data points towards there being a risk in generating these recursive dynamics, which might ultimately, either immediately or over time, or reasonably quickly, I should say, affect the quality of the generated outputs that are being created, which is interesting. Very, very
cool. Thanks.
Point. No worries. No, thank you, Paul. Are you working in that particular area yourself?
Look, we're working in regulations, and the challenge for us is LLMs. We can't have it hallucinated in any way. So we've kind of been investigating other models. I mean, you've got RAGs and other ways of fine tuning a model, but one simple two strawberry R's instead of three can be quite legally problematic. So it's been interesting. But I think this one had come up just in conversation with a person who actually recognized that his device that they used on him, it worked and it helped him, but it wasn't tested on humans previously. So
yeah, it's very, very interesting. And the legal liability for things like that hasn't completely been established in case law just yet, which is going to be interesting. I heard about an incident in the UK, I believe last week, where someone bought a foraging book as a present from a prominent online retailer. I won't name the name, but you all know what I'm talking about, right? And that book was given as a gift. It was completely AI generated, and they poisoned the family, right? So that's that's a problem, right? Because it contained pictures of mushrooms that it identified as non-toxic, but actually they were. So there's lots of regulatory adventures that we're all going to go on here in the next couple of years for sure.
Absolutely,
yeah. Excellent.
Anyone else? Any questions?
Hi, Mike.
Hi.
Excellent presentation. I could listen to you talk about AI for hours.
Oh, hi, Alex. Oh, that's too kind. That's too sweet of you. Thank you very much. I appreciate it.
Yeah. So from your perspective or your opinion, do you see this agent that creates other agents, is that going to be used for repeatable tasks, or creating agents sort of on the fly for ad hoc tasks?
Oh, that's very interesting. So I haven't thought about it in that way. I think one of the, so generally, so if I show you this, right? So this is, do you know, so the ARC prize, for anyone who's unfamiliar with the ARC prize, this is a particular benchmark that is a little bit different to other benchmarks that are out there, because it tries to benchmark artificial intelligence models specifically based on tasks that they were never trained on, right? Now, when with other benchmarking frameworks, right, generally what you have is you have a machine learning model that you train on solving a particular task, right? But that is not necessarily a sign of intelligence. I believe the hallmark of intelligence and the hallmark of this human benchmark is you encounter a problem that you've never seen before, right? And then you are tackling it with the logical faculties that you have at your behest, right? With a few exceptions, some of which are proprietary by Google, right? For instance, and you know, you can see some of the other open source competitors here that are submitting to the ARC prize, right? Most of the models that are being generated by hand right now, or by humans, I should say, serve a particular purpose. So it would be repeatable. Having said that, though, what I'm not accounting for here right now is the fact that artificial intelligence is now sort of getting a little bit of an upgrade, right? They're getting an XP boost, and they can improve themselves. So how quickly that's going to happen and how quickly they can adapt to new capabilities, that's going to be interesting to see. I have no idea. I hope that answers your question. Oh, Alex, you might be muted. Sorry.
Yeah. So when I was saying ad hoc, I was kind of thinking about like on-demand problem solving. But because there is a reinforcement learning component in the agent creation, that might be a bit slow. It's a bottleneck of sorts.
Yeah. Oh, so you're thinking of a service where you essentially go to a platform and say, create an agent for me that does X. Is that it?
Or not even create an agent for me that does X. It's just do X, and it will create the agent to do X and then do X.
That's very interesting. Look, I haven't seen because I think to facilitate an experience like that, you're right, we're probably a little bit early for that, I would assume. But I think we're sort of seeing the beginnings of that.
Early.
Having said it, though, there's a great startup idea for you in there, right? I mean, there probably were. I see. So here's the other thing, right? We talked about strawberries a lot. You're sitting in a backyard, which is very, very, very topical. There's a project currently being worked on at OpenAI called Project Strawberry. And Project Strawberry is supposed to be the next big model that they're putting out there. And the capability that Project Strawberry has is it isn't just, so previous models were essentially trained on data. I think GPT-4 was trained on data from 2022 or something like that. And you ask it a question, and it then, you know, relies on its probabilistic model to give you the responses and give you the answer. What Project Strawberry is supposed to do is it has the capability to, while you're asking it, surf the internet at the same time and improve on its response. Does so, surfs the internet anonymously, improve on this response just in time while it is delivering the response to you, right? So we might see that. That's supposed to come out in fall this year. So we might see the beginnings of what you've described coming reasonably early, if that makes sense. Because that's sort of like an agent that does additional things.
The Q-star algorithm.
Yes, correct. Q-star and Strawberry, part of the same project, I believe. Yes.
Yeah, I find the agent creating more agents fascinating. I want to play around with the source code. And the first thing I would do is get it to create itself and improve on itself.
Yeah, I mean,
just out of morbid curiosity to see if we all turn into paperclips.
Yeah, I think you're absolutely right. I think there's, improving on itself. I mean, there's a research paper in and of itself in there. So I wish you the best of luck. It sounds really exciting though, and probably a good idea in there for your own startup.
There's too many new things that are being researched at the moment, new discoveries, breakthroughs, and not enough time to try them all out, to play around with them. So it's a kind of a matter of sifting through what is going to last.
If you look at the if you look at, and I completely agree with you, if you look at the at archive and you search for federated learning for the month of August alone, we're talking 155 papers, right? That's a lot. So yeah, it's moving very, very quickly, very rapidly.
Fortunately, there's now an agent that can go and do the literature survey for you.
Right? That's right, and maybe that's true. But then you have the other one that's continuing to pump out papers like mad, so it's going to increase even further. Balancing each other out.
Yeah,
it's going to be fun.
I thought the Sakana part of it was massively interesting. The AI scientist seems like the beginning of the end. What limitations does it have at the moment for it to not go out of control and be unstoppable? I guess
It's so funny that you asked that question. So the first thing when you read through the blog post and the paper, what Sakana AI says, or maybe it's on the paper, it's not in the blog post, but what it says, hey, we want to give you a note about AI safety and security. It's very important for us that you don't misuse this. Also, the AI scientist bloopers, we have noticed that the AI scientist occasionally tries to increase its chance of success, such as modifying and launching its own execution scripts, which we, wanted to stop it from doing. And then it shows here when, Sakana AI it knows that it's not supposed to do that. So it's trying to find model ways to execute an execution script regardless. So it's trying to hack and jailbreak its own environment. This is interesting, That's exactly what you're talking about, Dylan.
That's what I meant. Yeah, exactly. Yeah, crazy. Absolutely crazy.
Yeah, totally.
Well, we've gone past 1, so we'll wrap this up. If obviously people have things to do today, work. But look, Mike, another amazing presentation. Really insightful, really interesting. Really looking forward to the next one.
Too kind.
Yeah, and thanks everyone for taking part.
Awesome. Thank you so much for joining. Thanks, Dylan. Thanks, Alex. Thanks, Luke. Thanks, Paul, and everyone else who was here. Have a great rest of your day. Take care.
Thanks, Mike.
Thanks, Mike.
Thank you. Bye.
Bye.